Hello friends, in this session we will study about the linear equations. The equations which represent straight lines are called linear equations. So we see how many types of equation are there. First of all, the straight lines, it means line in this way. Just I want to explain you. Straight lines would be like this. Is the straight line. If it is in curve, it is not a linear equation. If it is in this way, then it is not a linear equation. This is not a linear equation, it is a linear equation. Okay, this one is linear equation, this is not linear equation, the straight line. So we see how many types of the straight lines are there. There are one variable, two variables, and three variables straight lines are there. There may be more variables also there, but in geometrical representation only three variables linear equations is we have to study in our course. So that would be in the linear programming more than three variables. So we see here three variable linear, one variable, two variables, and three variables linear equation. First I explain you about this. You see here the types of linear equations. We have one variable linear equations, two variable linear equations, three variable linear equations. In one variable linear equation I explain you this thing here. Just like x minus 3 is equal to 0. So there is only one variable, x is variable and 3 is a constant, so it is a one variable linear equation. Or it may be like this also, 2x minus 5 is equal to 0. So there is also one variable. It may be like this, t plus 4 is equal to 0. It may be like this, y minus 3 is equal to 0. So these all are linear equations of one variable. In two variable linear equations we see that x plus y is equal to 3, 2x minus y is equal to 0, and x plus 4y is equal to minus 5. So these sort of equations are called two variable linear. There are two variables, x and y are there. Now three variables linear equations I explain you here. X plus y plus z is equal to 11. In this way 2x minus y plus z is equal to 2. There may be this sort of equations, 2x plus 3y minus z is equal to 0. So these are called three variable linear equations. So we see how we could represent on graph these equations. First we see, I draw a graph here. This is our x-axis, x-axis, this is our origin, and this is our y-axis. Okay, y days. Now I put some points on this line, like this one is 1, this one is 2, this one is 3, this one is 4, this one is 5. So in this way, here also in upward direction it would be positive, 1, 2, 3, 4, 5. On the left hand side of the this origin on x-axis would be negative, minus 1, minus 2, minus 3, minus 4, minus 5, and so on. Here also it would be negative, minus 1, minus 2, minus 3, minus 4, or minus 5, and so on. So in this way we could plot the points on the graph. Now we have to x minus 3 is equal to 0. This equation I am taking here. So we see what happens. X minus 3 is equal to 0. So x is equal to 3. So x is equal to 3 is this point, is x is equal to 3. So the line would pass through x is equal to 3 from here. It would be parallel to y-axis. So we draw a line here. So this would be line through x-axis passing through 3 on x-axis. So this is x minus 3 is equal to 0. So if it is the one variable linear equation, you see here one variable linear equation always parallel to an axis. If it is in the form of x, then it would be parallel to y axis, or if it is in the form of y, then it is parallel to x axis. Just we see here x minus 3 is equal to 0, oh sorry, y minus 3 is equal to 0. So you see y is equal to 3. So y is equal to 3 is here, so we draw another line here. So this line is y is equal to 3. Yeah, y minus 3 is equal to 0. So in this way we could easily draw the line on graph. So you see here the one specific characteristic of one variable linear equation, these are always parallel to an axis. So if it is in the terms of x, it would be parallel to y axis. If it is in terms of y, it is parallel to x axis. So this equation does not do not intersect both the axes simultaneously. It will cut only one axis, x, either x or y. Now we see the two variable linear equations here. I draw another graph here. This is our y axis, this is our x axis. Okay, I give some name to this and first try make it. I'm drawing this graph. This is our x days, y days, and this is our origin. We are taking points here also. 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, and 5. Here also minus 1, minus 2, minus 3, minus 4, minus 5. Here also negative 1, negative 2, negative 3, negative 4, and negative 5. So this we have taken here. Now we take one equation from this equation we are taking here, two variables, x plus y is equal to 2. So now x plus y is equal to 2 we take here. X plus y is equal to 2. So now let us see what happens. Y is equal to 2 minus x. Here x is the independent variable and y is the dependent. The value of y depends on x here in this equation. So we draw, if we take I take a list for this table. For this, you see here we are taking different points on this, like this is the x and this is y. If I put x is equal to 0, then I will get y is equal to 2. If I get put x is equal to 1, I will get y is equal to 1. If I get x is equal to minus 2, then I will get y is equal to 4. So if I get x is equal to 2, so I will get y is equal to 0. So in this way I could get different points on this line. These are the points on line which we have to draw here. So first point 0, 2, x is equal to 0 and y is equal to 2. This would be the point here. Another point we are drawing 1, 1, x is equal to 1 and y is equal to 1 would be here. Another point is minus 2, 4. So minus 2, x is equal to minus 2 and y is equal to 4. So it would be here. Okay. And one more point we are getting here, 2, x is equal to 2, y is equal to 0. So x is equal to 2, y is equal to 0. So we have draw these 4 points here. You may draw only 2 points also, because from 2 point a unique line pass through the 2 points. So here we are taken 4 points because there is no any clue for any mistake in the calculation. So we have taken more than 2 points, 3 points or 4 points. If you mistake some if you do some mistake in calculation, so it could be rectified. Now we draw a line. We draw this line here. To this point we draw a line. So you see all the points are on this line. So this is the required line which we have to produce through this equation, x plus y is equal to 2. So we could draw in this way, or we could write that x plus y is equal to 2. This is the equation of this line. So by this equation you first specific characteristic you see here. You see here that this line intersect both the coordinate axis. It intersects and y axis it intersects also the x axis it intersects too. So this is the specific characteristics. One more thing I would like to tell you, if we have an equation like that, I change the color here first and make it some 2x minus y is equal to 0. So we see what happens here now. 2x minus y is equal to 0. So we draw another table here for this. Now only 3 points we take here. Now this is x, this is y. So y is equal to 2x here for this. If we simplify this, y is equal to 2x. If we put x is equal to 0, y is equal to 0, x is equal to 1, y is equal to 2, and x is equal to 2, then y is equal to 4. So we have 3 points here. We will draw these points here. So I will put these points with blue dots. So first point is 0 0, so it would be at origin. Second point is 1 2, x is equal to 1 and y is equal to 2, so I will get here. Third point is 2 4, so this is 2 and this one is 4, so I will get here. Okay, so in this way I will get the points, and if I draw the line through this point, so we see what happens. I draw a line with this color. Okay, so you see here, just draw a line. So this all 3 points on this line, I change the color here. So you see this is the required line, 2x minus y is equal to u. One specific characteristics of this sort of equation where the constant term is 0. Constant is 0. You look here, the constant here is 0. This constant is 0, so it always through the origin, passes through the origin. So this sort of line always passes through the origin if there is constant is 0. Now I would like to explain you about general equation of a straight line. So you see the general equation of straight line of 2 variables. So the general equation look like this: x plus by plus c is equal to 0. This would be the general equation of the straight line, where a is the coefficient of x, b is the coefficient of y, and c is a constant. Basically a, b, c all are constant, but they are the coefficient, and this is the independent coefficient, constant, independent constant here, c is. So if we have to find out the system of lines, what is the system of lines, I would like to explain. The system of line is what? System of lines where more than two lines are there in a system, or the relationship between these lines we can watch through the different aspects. So we see there may be in two variable equations, we must have two equations. If there are two variables, there is a need of two equations in a system minimum. If there are three variables, we need three equations in a system minimum. There may be more than three equations also, but the minimum is requirement for a system according to the variables. If the variables is 2, there is requirement of 2 equations. If the variable is 3, requirement of 3 equations, the minimum requirements of the equations. So let us see how many types of systems in two variables, systems of lines in two variables. So let us see here. First I draw the first system is called the transversal system. Transversal system. This is a transversal system where the both the straight lines intersect each other somewhere. So there is a unique solution we get here. The common point is only one. In this sort of equation, there is only one common point. Which one is the intersecting point? Would be 1. This is the intersecting point. Point of two lines is a unique solution. It will give us the unique solution. We will get the unique solution here. So I explain you here. It is we get the unique solution. Unique solution is there, and this unique solution, or we could also say this one and only one solution we will get here. One and only one solution. Okay. So in transversal system where the both the lines intersect each other at a unique point is called the transversal system, and it would give us the unique solution, or the one and only one solution is there. If we have two lines like this, the equation I write here in this way. First equation is a1x plus v1y plus c1 is equal to 0. This is equation 1, and we have another equation a2x plus b2y plus c2 is equal to 0. This is another equation we have. For unique solution, we get the ratio of the coefficient of x is not equal to the ratio of coefficient of y. If both the ratios are not equal, then it shows the unique solution. So I would write in this way: a1 over a2 is not equal to b1 over b2, then it represents unique solution. Okay, this is the first way to get the transversal system. We could easily find it out. We just have to put the coefficient of x and the coefficient of y in the ratio. If these ratios are not equal, then the both lines represents transversal system. Now we have another system, number 2. Number 2 is parallel system. Parallel system. In parallel system, I draw the line here first. One line is this, and second line I draw here again. This line is this. If the both lines are parallel to each other, it is called the parallel system. There is no unique point on both the lines which satisfy both the lines. So here it is called the parallel system. And for in algebraic form, if we have to find out the whether it is parallel system or not, so we have already two equation: a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So if the ratio of the coefficient of x is equal to the ratio of coefficient of y but not equal to the ratio of the constant terms, so it is called the parallel system. It represents the parallel system. So I would like to write here, if the ratio of coefficient of x is equal to ratio of coefficient of y but not equal to ratio of the constant, so it represents parallel system. There is no unique point on the lines which satisfy both the equation. There is no any point. So now we see the third one. Third one is the coincide system. In coincide system, I explain you the line here. I draw two lines, some thicker lines I draw here. First one I draw red, okay, and second one I draw a blue line, little bit thin. Okay, first this would be red. Now second one is should be thin blue line. I draw here. You see, you see here both lines are coincident, overlapping to each other. Blue line and the red line both are overlapping to each other, so it is called the coincide system, where the each and every point satisfy both the equation. There are so many infinite points on a line, or these satisfied both the equations, so it is called the coincide system. Here you see what will the algebraic relationship between them. So I explain here. You see, the coefficient of x, ratio of the coefficient of x is equal to ratio of coefficient of y is also equal to the ratio of coefficient of ratio of the constant, sorry. So it is equal to the ratio, all the ratios are equal, then it represents the coincide system. It will give us infinite solutions, many solutions, or infinite solutions we will get over here, or we could write many solutions. Here in parallel system there is no solution because there is no any common point for both the lines which satisfy both the equations, so it will represent no solution. There would be no solution. So you see here, in transversal system we get unique solution, in parallel system we get no solution, and in coincide system we get infinite solutions. So where we get the solution, either it is unique or infinite, it is called the consistent system. Consistent systems are: number one, transversal system are always consistent. Number second, coincide system are always consistent. Okay, so these two sort of system, because here we get the unique solution and here we get infinite solution. So these both we get some solutions here, so they are the consistent system, and the parallel system is not consistent system. In the next session we would study about some different things regarding the methodology to solve the two variable linear equations, one variable linear equations, and three variable linear equations. There are different methods to solve the two variable linear equations and the three variable linear equations. So